Hello everyone, welcome to AI Anytime channel. In this video, we are going to build our own AI agent ops library. So we're going to create a Python library that will basically helps you with the operational part or the monitoring part of AI agents. If you have been working in the field of AI or machine learning, you would have heard the terminologies like ML ops, AI ops, data ops, so on and so forth. Nowadays, we are talking about LLM ops or the agent ops. Operational monitoring is a critical aspect when you build an AI application. And that's what we're gonna do in this video. I'll show you that how you can create or build your own Python library. There's no fun when you use already available, libraries or frameworks like AgentOps or Langsmith, or Arize AI, Phoenix, or Weights and Biases Weave. There are multiple tools out there in the market. That's good if you utilize it. There are different perspective to it. If you are someone who is new, and who's trying to learn things, I will recommend you that you should focus on the fundamentals. You should learn how these guys have created or built these kind of frameworks or libraries, or of course made it available through API or platform, right? You should learn that then how you learn this technology faster. If you're just gonna rely on the wrappers, then eventually you will not be of any use in near future, right? Because people who are working with the wrappers, they have no scope, to be honest. So you should keep this in mind, where you should learn how to build these things from scratch without relying on any kind of frameworks and so on and so forth. Now, if you are using Crew AI, for example, to build AI agents, how you can bring up your own, ops or monitoring, framework, you know, couple that with Crew AI agents and basically find out all the logs and all the monitoring that you want to do. That's where it's important for you to learn. Now, if you're working in an enterprise, for example, if you're working, for big companies, then there are also two perspectives to it. Most of the client will like to rely on the hyperscalers, the cloud, where they would have the observability or monitoring tool because they have the enterprise licenses. Then you should not worry about, these things in that case. The other perspective to it is that if your data is really sensitive and you are worried about confidentiality, then you might want to bring up everything that has been developed in-house. So in this video, focus is to I'll show you how you can create a Python library that will work with Crew AI for now, but later of course you can expand that to other frameworks like AutoGPT and LangGraph and Swamps and so on and so forth. So let's jump in and see what we're going to do in this video. So you look at here on my screen. I already have created this. That's called AgentWatch. So we named it AgentWatch, which is already on PyPy here, which is version 0.1.2. You can see it says pip install AgentWatch. That's how you're gonna install it. Has a bit of readmes and a bit of details. So the library is already live. Let me show you how you can run this. But before that, I talked about multiple tools. One is called AgentOps.ai. They are now startup guys. They are making millions and millions dollars, or they have in the funding, right? Then you can also do that if they can. It's not rocket science. You should, of course, know the fundamentals. It takes time. Building a startup or a venture is not about having a product. It's beyond that. But the idea is that you should start looking at these concepts, how you can build it. The same goes with Langsmith, which is more of a, of course, hybrid, I will say, more open source thingy. And then, of course, they give it through their cloud as well. You have weights and biases, very famous. Wanda B. Uh, we have been using it since machine learning days when we were using machine learning algorithms. And then we have Phoenix by Arize. If you look at here, it says open source LM tracing and evaluation. These are all fine. These have been built and developed, right, by people, the team, the community out there. How you can do the same thing, right? You can at least start and form a team and basically expand that. Now, it's completely available on GitHub. Right now it's private. We'll make it public soon. It's called AgentWatch. You can see it over here, a very well documented repository. This is how the output will look like. If you look at the AgentWatch summary, total time, input tokens, output tokens, total tokens, cost, average CPU uses, average memory uses, carbon emissions, so on and so forth. So everything that is here. Of course, you can add more things over here, guys, based on the logic that you want to develop. And if you come down, it shows how you can install this. So you're gonna do pip install AgentWatch. How does the users look like? This is how you're gonna use this. If you want to use this with Crew AI, there is an example with Crew AI, how you're gonna use it. Feel free to have a look and use this. The API references, of course, have also explained how you're gonna, because it's open source, right? I'm building it for you guys, so you can take this and make it 10x from here, right? So if you look at the API references, it has that over here. And then not only that, you can also use this, all this output, the result on a Streamlit interface. Now that's what tools like, I forgot the name of the tool. There was a tool that basically comes up on a Streamlit interfaces. So you can also visualize it. Basically, that's what it is. You can have some charts. That's what AgentOps does. Okay, they have some charts and visuals, with some logging and stuff. So you can also do that. It's not rocket science. That's what I'm trying to say. You can look at here, visualize.py over here, and then running the Streamlit contribution. Uh, Happy to accept some PR on this. If you please open a pull request if you want to add some new features and if you want to contribute to it, because we're also going to propose this in we're going to do a preprint, of course, and propose through a paper so other guys can build it. So happy to, accept some PR on this, if you want some pull request. Okay. And of course, we can extend this further. So very well documented open source repository that you can use it completely. Feel free to use it. Now let me show you how it works. You can see I already have pip install agent watch here installed. Let me install it. You can see it's installing it. Make sure that it's installed this version, which is 0.1.2. I have made some changes. So you can see requirement already satisfied, blah, blah, blah. Okay, so that is done. If you look at this package, now we're going to rely on like Crew AI, because Crew AI has been one of the most used agent frameworks. So I assume that you have been building your agents using Crew AI most of the time. But right now we're also working on to make this compatible with AutoGPT, LangGraph, and Swarm. So that will also be out very soon. And if you scroll down, this is what I'm using. So from AgentWatch, which is the library that I've created here, you can see AgentWatch, and I'm going to walk you through the code and everything, how you're going to do that. But before it, I'm using import AgentWatch extended. This is what we have. From Crew AI tools, we have scrap website tools, file writer, and text search tools. So basically, we're gonna basically scrap a website, keep that in a file, and use like a vectorize and keep it through like ChromaDB or something, and then use the text search tool that Crew AI provides. And then Crew AI, we're gonna use, of course, agent task crew, and couple of utils thing over here to fetch the envs. For the demo purpose, I'm using GPT-4o, so I need OpenAI keys to work with. So let me just do that here. So I'm just gonna do this, and now what I'm doing, we're gonna initialize the agent watch. Pretty much straightforward. So I have a variable called rag_watch, and I'm using this agent watch extended class. And in this, I'm passing the model name. And of course, once I show you the code, you will understand the parameters and all the args and quarks thing. So let me just run this here. Initialize agent watch. When you run this, it will show you an object. It means that has been successfully initialized. And once you have initialized it, you have to start monitoring. So you have to run this. This will be on the top of your Crew AI code before you start running the agent and stuff, right? So I'm gonna just do rag watch.start. It will show monitoring is started. You can see it over here. And then I'm scrapping a website here. You can see artificial intelligence Wikipedia page. I'm just scrapping it. So let me just do that. You can see it says using tool read website content. It has done it. Let's get the first 500 character of this text here from the scrap text. So I've just done that. Now here, I'm initializing the file writer tool. Now this tool is coming from Crew AI, but nothing is stopping you to create your own tool using Crawl for AI, Gina Reader, Docklink, blah, blah, blah. There are thousands of other that you can use to build your own tool and use it through Crew AI or any other framework. Now here I have file writer tool, blah, blah, blah. I write that to a file called ai.txt. So let's do that. So you can see now I have written this in this ai.txt file, right? This is all of your wiki thingy here. Now I'm using text search tool and passing that text file called AI.txt. You can use PDF search tool. You can use any other files as well. And my question is, what is natural language processing? and I'm expecting it that it will answer it. Now, for that, you can see it says using tools, search, TXT, blah, blah, blah. It answers it, what is natural language processing and all of those things, right? So this is an output. Now I create three different, I create an agent as a data analyst agent, have given a role, there's a goal, there's a backstory, pretty much crew AI thingy. We're passing a tool. It can be one tool or multiple tool. So here you can see we are using a list and passing the tool that we have defined here called text search tool. So let's just do that, and then creating the task here. So we have a task, giving the task, understand the topic and give the correct response, provide a correct response about NLP, and then just creating the crew. So let's do that. And I'm gonna run this. So once I run this, agent will converse with each other. If there are multiple agents, but here's only single agents. So you can see the output will be below here. There will be an output. You can see this is the crew output. It shows NLP allows program, blah, blah, blah. It gives you the answer. Let's get the output text. And this is where we are using ragwatch.set token uses from crew output. So I'm just gonna run this. And you can see the output over here, like not the output, these are crew AI input tokens, output tokens, total tokens, and the cost for the model that we are running, GPT-4o. And I'm going to show you how it is being calculated. And then I'm going to end the monitoring and then visualize. So right now we have two methods. One is through CLI and the other is through Streamlit interfaces. So if you want to do it through Streamlit, of course you have to do it through Streamlit. Then you have to probably run a bit different way in Google Colab. But if you're running it locally, then that is fine. That will open a new tab or a browser. So here I'm doing CLI. Once I do that, it will show you the agent's watch summary. So if you look at the summary, this is what it says. Total time it took to perform the task, like the entire, because eventually you will deploy this as an endpoint, or you'll basically run this in an app.py file or a Python file. So it basically find out all the time it took to run the entire script or the APIs or the functions, whatever. Now, if you look at the total time, the input tokens, the output tokens, the total tokens, the cost, average CPU uses, and average memory uses as well, and then the carbon emissions of it. How are we calculating carbon emissions and everything? I'll show you and also give you a bit more hint that how you can, of course, scale this further. So this is what we are doing. You can bring up a lot of other things like the questions, the output, the verbose, and you can add it over here to make it fancy. That's how AgentOps does here. Nothing against these thing, guys. AgentOps, Langsmith, Wenderby, Phoenix, these are all good. Everybody is, doing some kind of business or they are helping the community, all fine. For me, my ethics is that, or my aspirations are that I want to create content that will help you guys do better in the field of AI, really understand the need of the future, where after 1 year, these kind of frameworks and tools uh, will be really hyped. It's already hyped up. You need ops tool, guys, to be honest. That's what enterprises also looks at it. And I want to make it accessible. I want to make it free for people so they can just watch the video and do it. Like that's why I make this project open source on my GitHub. So this is what it does. You can see a working demo of it live. You can make it, you can improve this further. I was inspired by AgentOps. That's why they also have AgentOps at the start or end or something like that. Stop. That's why I also did that end here. And in the beginning, I have here start. So I've done the same thing. So I was inspired by them. Credit to AgentOps for doing that. So this is done. Now the library is already published on PyPy and the GitHub code is also there. So everything is there for you. You just have to take this, work on it, make it better. Of course, make it your own. I don't have to, you do not have to even give credits to me, to be honest. Okay. So let me come here on the VS Code. Okay. Now to build these kind of libraries, what do you have to do? Okay. Pretty simple. I will walk you through the code. Forget about this egg-info folder, build folder, dist folder. I'll show you how you can create this folder. These are all automatically created when you basically build the library and you use some kind of like managers like Twine, for example, or Wine, whatever you call it, or I don't know how to pronunciate it, but yeah, that's how you do it. You need to create AgentWatch folder. You need to create test folder, and then you need these files. Okay, like uh, you need a license, which is of course an MIT license. You have manifest, py project 2ml and readmes, and a setup.py is very important. Let's have a look at setup.py first. Now in the setup.py, this is your main file that will help you publish the library, like where you have requirements, you have some information that will be helpful. See this more as a package JSON if you have ever worked with JavaScript. Now if you look at here, you know it says long description. If you look at this description over here on this package, this is where coming from a README file. So we are defining it over here. And then we have a setup over here that if you look at this setup, we are giving it a name, giving it a version. Every time you make any changes, you can make a CI/CD as well. But whenever you make changes and want to republish the library, it's a good practice to update the version. Okay, that's why you would have seen that people say that, okay, LangGraph or LangChain version is not working, downgrade the version or upgrade the version. So version is very important. I'm giving a name, I'm giving my email, I'm giving a short description. Long description is coming from this long description. And then I have GitHub repository, and then I have some packages, which is find packages, and I'm defining these are some classifiers, blah, blah, blah. And here I have requirements. So I'm saying use Python 3.8 and greater than 3.8, the latest versions of Python. And then these are the requirement. PS util, because it's important for CPU and memory uses and so on and so forth. Then we have matplotlib for some kind of visualizations, on Streamlit if you want, Streamlit, and tick token for counting the tokens, which is important because Crew AI provides these tokens, but the idea is to make this compatible with AutoGPT and LangGraph and Swarms and other thing as well. So you need tick token or any other token kind of uh, token counting, I'll say, of package or a library. So this is our setup file. Now in the AgentWatch, we have an init.py. If you look at the init.py, there's basically all the classes that we have, the API specifications for AgentWatch, the AgentWatch extended. I'm going to show you that. And then we have cost calculator. We have defined the pricing for two LLMs for now. You can see GPT-4o and GPT-4o mini. We can define it for Claude Anthropics, Geminis, and other models as well over here. And then this gets calculated over here. There's a function that we have that calculates the cost, takes up the input tokens and the output tokens, and then basically gives you the return of total cost. Then we have a logger file, which is pretty much straightforward. You can use some libraries like Loggeroo and stuff as well, but here I am using logging. If you look at here, and then I'm using basic Python supported loggers, and I'm just it basically creates this file, agentwatch.log. If you look at here, the idea is to show you guys that how you can fundamentally build this. Of course, it's up to you. Invest some time to make it better. And if you look at monitor.py, this is your main file. So let me just show you. Now in the monitor.py, I have a class called AgentWatch. And then I have a class called AgentWatch extended that basically, inherit the AgentWatch class, that has been on top. Now, if you look at this class AgentWatch, in this I have multiple functions. Now, in the first function, which is your init function, I have monitoring, which is a tool, Boolean value, so make it true. I have the model, which is model name, start time, end time, some argument that I have defined. And for these tokens, it should be 0 by like default. There's no tokens. CPU uses, memory uses, some cost calculator using that function, cost calculator. Not the function, by the way, there should be a class. Okay, here, yes, class cost calculator, which is defined here in this cost calculator. If you look at this, yes. Now cost calculator, and then some monitoring thread, carbon emissions, 0 by default. And if you are not using Crew AI and if you want to use like other frameworks and you want to count the tokens, like the input tokens, and agents also converse, there is a dialogue that happens between multi-agents that you create, right? Multiple agents. Then you're going to use some kind of encoders, that's coming from tick token, and use some kind of models that will count the characters, basically the tokens. So we are using STL 100K base, which is like pretty standard model to do that. And then we have like monitoring, which is Boolean value, true, false, have some start, that starts it, the thread, and then it ends it, and it basically calculates everything. And then monitor resources, looks at your CPU and memory and everything, looks at your token counts, and from crew output. So this is what I want to show you. Now these two functions that you see, set token counts and set token counts from crew, these two, there are different. There are different between a difference between these two. The first one is compatible with other frameworks because you don't need to count tokens if you are using Crew AI, because Crew AI output gives you those, okay, in the output itself. So you just have to parse that. So we're just parsing it over here, for, if you look at it, it says if has attribute. So we are using has attribute Python function. Within that, we passes the crew output and use this text called token underscore uses and get this output. That's what we are doing here, right? And then in this AgentWatch, we are using Streamlit and CLI, like some conditional. If you have a Streamlit, of course, we're going to do a Streamlit dashboard and stuff. So let me just go back here. Utils.py. Here I have uh, taken some numbers from internet that how much this model can cost for each API calls that you make, for GPT-4o, GPT-4o mini. But if you want to make it a bit more comprehensive, CO2 emissions are really important when it comes to sustainability. Most of the companies are looking at uh, how to build uh, how to build optimized software which is not emitting a lot of carbon. When sustainability is a complex topic, guys, there are different types of emissions: scope 1, scope 2, scope 3, blah blah blah. So when you come into this field, it has to be really really comprehensive. So keep this in mind. I'll also recommend that you can look at CPU uses, the memories, the time, and combine that and create a formula that will help you calculate. Also multiply that with your country's emission code. So the user, if user is from United States, then United States has a different emission factor. If the user is from India, then India has a different carbon emission factor. So it depends that from in which country the user is from. So, but here we have taken some numbers from internet to calculate the carbon emissions. You can see it over here, kg CO2 per token. Now, in the visualizer, we have a visualizer for CLI and Streamlit. So this is for the CLI thingy that it basically prints it. This is the print output that you see here in the agent log. These are all coming from CLI output. Now in the below one, we have a Streamlit dashboard where we'll basically write it, and we have some kind of plots. I'll recommend that you run this. Basically, you need a separate script to run this because it runs in a Python file again in a tab. But that makes a lot of sense because then we'll have a visuals, right? People will like it. Okay. So this is your Streamlit dashboard. Now this is one folder which is AgentWatch where you write all the code. The next one is test folder. In the test folder, you have test AgentWatch. This is important because this will help you. You should not directly publish your library. You should first test it locally. And that's why you need a test agentwatch.py file where you can test all the, it basically runs all the test and passes it or fails it, right? So we have this test. Now, log I have shown you, I have an MIT license. So I have shown you this MIT license. Manifest, I have shown you to include README and licenses in manifest. In Py project, we have requires called setup tools and wheels and build system. This is important for Python libraries. And then setup I have shown you already, and this is your README. I have shown you the setup. Okay. Now, how do you build this? Okay, how do you basically run this and build this as a library and publish it on PyP? Okay, the thing is, you have to come here and take your API keys. So go to account settings. I think I have to log in here. Okay, it will ask me for authenticator. Okay, it didn't ask me because I was just logged in. Okay, now here you will find an API keys. If you look at the API tokens, you first need an API tokens, keep it safe somewhere. Just like you use OpenAI keys, you need a PyP API keys as well. Once you have done that, you go back to your VS Code, or like of course have a terminal course, and then you have to run. You first have to install and of course test it locally. You can look at here, I'm testing it locally, called python-m unit test discover. Make sure that you install everything. Better to create a virtual environment. You can see I have a virtual environment over here. In this virtual environment, all the libraries will be installed, which is required. And you can basically install this by using this command, which is pip install hyphen, which is not hyphen, pip install dot. Okay, that will install from your setup.py file all the libraries in that virtual environment. And then you can use this this command to basically test it, and it will pass all the tests. Once you do that, you need to, of course, upgrade. It's better to upgrade setup tools, wheels, and twine. Twine is important, or however you pronunciate it. And if you look at here, we are building the wheel. You can say it says Python setup.py sdist and bdist underscore wheel. Once you do that, it will create this folder here in the left hand side called build and dist. So if you open dist, it basically creates the zip file and wheel of it. You can see it over here for your code and everything. In the build, we have libraries. In the library, it takes two folders, as I said, right? Only two folders are important, guys. One is AgentWatch, the other is tests. The AgentWatch, you can find out everything, all the code, the same thing. And in the test, there are two files. So basically, it creates this folder which gets uploaded on PyP. Okay, now you got that point. So you have to run this Python setup.py sdist bdist will, and then you have to just let me show you. Actually, I took a reverse one. You just have to do upload that using twine or whatever you call this. Okay, there are other ways you can also do it. Upload this. Once you do it, it will show you some loaders and it will show you how, like, if it's completed or not. Once that is done, then you are good. You publish your library. You can see this is how it done. It does it. I just did it. So you see here, when you do this command, it says uploading distributions to PyP. Enter your API token. You have to. It will give you the prompt to enter the token, and then you have to enter it, and then you have to. Then it will automatically start uploading, and then you can view it over here. Make sure that you have tested it locally. All the tests have been passed. There is no errors, and then you publish it. Okay. So this is how it works, guys. Pretty simple. I hope you got a bit of idea. Go through the GitHub repository. If you have any questions, thought, feedback, create an issue here in the issue sections, and I'll happy to help you. Get it done as well. Happy to see if you are okay to contribute. We are also writing a paper. If you want to take part in it, please write to me. I will also include your work as well in this. Of course, we are enhancing it more. We have a community. I'll open this to the community internally on Discord and WhatsApp. We will take more contributors. I want to make it compatible with AutoGPT, LangGraph, and Swarm, at least these 3, 4, and also custom without any frameworks as well. We created a videos on how you can create your own agents without any framework in pure Python. That's how you learn it, guys. That's how you become better in this technology, not only by calling API calls and by reading somebody else's, like work and stuff. You have to do it yourself from scratch, build it, make errors, make mistakes. You will get thousands of errors, then fix it and solve it and do it. Okay. That's all for this video, guys. I hope you got a bit of idea. If you have any question, thoughts, or feedbacks, let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos. Please join our Discord community. We'll give the link in description. You can also join our WhatsApp group where we have really great conversations about AI. Okay. That's all for this video. Thank you so much for watching. See you in the next one.